All right, group, last example of our lesson 3 notes here. It says a ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters per second. The equation here can be used to model our situation. Make sure we include our units. We already have our graph, which is a beautiful thing. However, we know that these aren't going to be perfect, right? We know that these aren't going to be perfect. So we want to do our best to read these. If we needed precise answers, we would definitely use Desmos, okay? All right, it says, when does the ball hit the ground? Remember, when implies time. So time is always down here. This is our time in seconds. And this is our height in meters. Okay, so when does it hit the ground? Right here at 3 seconds. What is the height of the ball at t equals 1? T equals 1's right there, and that's 12 meters. Okay, what is the y-intercept? Right here, 0, 3. So when we're trying to explain this, let's think back to what they said here. A ball is thrown straight up from 3 meters above the ground with the velocity of 14 meters per second. So the ball is thrown straight up from 3 meters above the ground. The ball starts at 3 meters in the air. Okay, find f of 2. Interpret the context. Okay, f of 2 would be f of t, so time is 2, and that is 11. F of 2 equals 11, so this means at time 2, the height is 11. So, to make that sound a little bit better, after 2 seconds, the ball is 11 meters in the air. Okay, it says now use Desmos to help answer the following. Okay, so we're going to have to go ahead and put our equation into Desmos. Oops. Okay, we're going to create let's create a table. I think it's easier to see it from a table. You could use the graph as well if you wanted. Okay, so it says, when is the ball at the highest point? Okay, the highest point. So if I keep adding some numbers here, I can make a good guess, right? It looks like somewhere around 1. So let's go ahead and use our graph, and if we tap at that highest point, it shows us 1.4, 12.8. That's not something that we could actually ever see just from a drawn graph. So we're going to go ahead and write that in. .4, 12.8. Okay, and it asks when. And when is our time, which is our x value. So it'd be 1.4 seconds. Okay, what is the height at that point? The height would be the 12.8 meters, of course. Okay, then it says find f of 2.5. Okay, so I'm going to go in my table and I'm going to type in 2.5, and Desmos tells me it's 6.75. So we know that this is time and this is height. So for a good sentence, we would say after 2.5 seconds. The ball was 6.75 meters. In the air. Okay, and our last question. How many total seconds is the ball in the air? So right here it starts in the air, right? And then here it lands. So that would be 3 seconds.